Welcome to Brain Vision.
So at what distance from equilibrium will velocity have half of its maximum velocity? And then for part B, they're asking for the acceleration, the distance from equilibrium where the acceleration is half of its maximum acceleration. So we have a mass, and then it is stretched a distance of x naught, or x sub o. And we can say that v is going to be equal to plus or minus v max times 1 minus x squared over a squared. So essentially, this is going to be equal to v max over 2. And we can say that plus or minus the square root of 1 minus x squared over a squared is going to be equal to 1 over 2, which means that 1 minus x squared divided by a squared is going to be equal to 1 over 4. And we can say that for part A, x squared over a squared will equal 3 over 4. And then we're trying to find x. So x naught is going to be equal to plus or minus a radical 3 over 2, or we can say plus or minus 0.866a. So essentially, the velocity will be half of the maximum velocity when the stretched distance is equaling plus or minus 0.866 of the amplitude, the maximum x displacement. Now for part B, they're asking us for the displacement from equilibrium such that the acceleration is half of its max acceleration. So because F equals kx equals ma, the only force on this object is the force of a spring. So according to Hooke's law, it's going to be negative kx. And we can see that acceleration is proportional to displacement. So the acceleration will have half of its maximum value so we can say a max over 2 occurs at x naught equaling plus or minus a over, rather we can say a max occurs at x naught equaling plus or minus a over 2. So essentially, because the acceleration is proportional to displacement, albeit in the opposite direction, the acceleration will have half of its maximum value when the stretched distance is at half of its maximum displacement. So that'll be the and that's the this will be your answer for part B, and then this will be your answer for part A. That is the end of the solution. Thank you for watching.